Okay, then we shall start. Okay, so we had we have seen already how to uh, check whether a given set of variables form a basis. That we have seen. Now suppose that you have a basis and the corresponding BFS. I mean a BFS. Every basis need not correspond to a basic feasible solution. I mean every basis will correspond to a solution. Those are basic solutions. If the entries are greater than equal to 0, then it is a basic feasible solution. So suppose that we have a BTP and assume that we have a BFS, call it W. Now what we know is the following. We know that the coefficient matrix A, which has m plus n rows, we know that the rank is m plus n minus 1. Okay, and we also know that each of the rows is a linear combination of the remaining. So we are free to delete any one of them because it basically means it's a set of m plus n linear equations given. It's a system of equations given. One equation is unnecessary. I mean, it's just useless. So you can throw away one equation. So here let us throw away the last equation. So the last row, drop the last row. And the matrix that you are getting, call it A tilde. Okay. So then this A tilde matrix has m plus n minus 1, that many rows. Fine. So that is not the point. Imagine our, try to recall our old days. In the LPP days, what we used to do now, if I have a problem of SLPP, minimize C transpose X subject to AX equal to B. Here rank was m by n. So like matrix was m by n, rank was full rank. Okay. And suppose that I had a basis B, basis matrix B. This was how did I know? So corresponding to this basis matrix, and suppose we have the like some V, let me write V, the BFS. So how did we know? What was the test to know that V is minimal? Now to know that V is minimal or not, what we had to do, we had to compute the relative cost. And how did you compute the relative cost? Now relative cost was computed as C bar transpose is obtained from C transpose minus CB transpose B inverse A. This is how we computed. So here also, how do I find out whether our BFSW is minimal or not? Now, this was whatever right now I have written. This is for old LPP. This is the knowledge from old LPP. So right now what I have to do? Now I have to find out C transpose minus C B tilde transpose. Acha, since the matrix is now B tilde and A matrix is A tilde, so let B tilde be the basis matrix. So B tilde is basically those columns of A tilde selected, I mean, so uh, for the variables, okay, for the variables of, for the basic variables that are given with W. So it is basically the basis matrix of A and deleted the last row. Okay, so this is basis matrix. Now so CB this B tilde inverse A. This is what I am supposed to compute, and I am supposed to know whether this is greater than equal to 0. That is what it is. Now suppose that instead of computing, suppose somehow I computed for some A, not A, but A tilde. Okay. Suppose that instead of computing CB transpose B tilde inverse, CB tilde transpose and B tilde inverse, I somehow found a vector alpha such that alpha transpose A tilde, okay, has basic entry 0. Here it is unnecessarily given that greater than equal to 0. You don't care. This part is not necessary. Has basic entries 0. Okay. Does this imply, will it always imply that alpha transpose is equal to CB tilde transpose B tilde inverse? Is it true? Now the answer is yes. And this argument we have already seen. If you do not remember, try to, I mean, it is easy to remember it. For example, okay, has basic entry 0. So if you try to remember, let me recall it for the old LPP, what we did. See, if you have C transpose minus alpha transpose A, this is nothing but, I am trying to recall from, okay, old LPP. This is nothing but CB transpose CC transpose minus alpha transpose BC. If I write, if you allow me to write the matrix A as BC for simplicity. So then that, and you are saying the of this relative cost vector C, like C transpose minus alpha transpose A has basic entry 0. This basically means has basic entries 0 means CB transpose will be equal to alpha transpose B, and so alpha transpose will be CB transpose B inverse. So here what is happening now, here instead of A we have A tilde, and instead of B we are calling the basis matrix B tilde. Okay, so that is how, so that is why this is yes. Okay, So what is happening? Now you have the matrix A tilde obtained from A by removing the last row, and then somehow if you can find a vector alpha transpose such that C transpose minus alpha transpose A tilde has basic entry 0, then you know in that case this C transpose minus alpha transpose A tilde will be your C bar transpose. Okay. Now the idea is that, okay, you actually do not have to take just alpha transpose. If you extend the alpha transpose vector by one more entry 0, so if you take C transpose minus alpha transpose and then extend it by 0, and there you extend A tilde by to A, so you include the last row and the last row gets multiplied by 0. This is the same thing. This is the same as C transpose minus alpha transpose A tilde is the same as this one. So then what is your idea? The idea is that somehow I should find a beta. So if you call this as beta, somehow you should find, so idea is then find a beta such that C transpose minus beta transpose A has basic entries 0. And then C transpose minus beta transpose A is equal to C bar transpose. So that is what item A and B are saying. Okay. Fine. So assume that you have done that. That is your C bar transpose. You have done. Okay. That you have found a beta transpose and somehow such that the C bar transpose has basic entry 0. So that is it. Okay.
Excuse me, sir.
Yeah.
Sir, could you repeat that idea once again? Just I wasn't able to understand that clearly.
Actually, there is not much. Oh, wait a minute. I am hearing some voice, some noise. Why am I hearing? Okay. Are you able to hear now?
Yes, sir.
Okay. Yeah, there was some noise somewhere. So what I was saying is the following. You don't look at what I have said here. See, suppose that you are looking at one LPP where you are minimizing C transpose X subject to Ax equal to B. Okay. Now you are at a basis. You are at a BFS. So that is a vertex. You are at a BFS W. And the corresponding basis matrix is B. Okay. Now, how do you compute? How do you know you are at a minimal BFS? Now you find out C bar transpose. That is, compute the relative cost vector. How do you compute the relative cost vector? Now, in order to compute the relative cost vector, the formula is that C bar transpose is equal to C transpose minus CB B inverse A. This is the formula. Okay. So you apply that here. Acha. before that, even from LPP days. So this is the formula given. Now your friend once comes, he says, look, I have found a vector alpha and I computed C transpose minus alpha transpose A. And whatever is this resulting vector has basic entry 0. Okay. Now can you say that this vector is actually C bar transpose? Can you say that this vector is actually C bar transpose? The answer is yes. We can say. That is what I showed actually, because C transpose can be written as CB transpose CC transpose, A can be written as BC, and then from there you can see that alpha transpose is actually this CB transpose B inverse. It will turn out to be that. So how do you compute your C bar? C bar transpose, either you compute using the first formula or use the second idea, and somehow by doing some magic you get a alpha transpose such that C transpose minus alpha transpose A has basic entry 0. If you can get that, then the resulting vector is nothing but C bar transpose. Okay, so that is the idea, and that is the old idea in fact. But here what is happening now, here my matrix is m plus n, having m plus n rows, and one of them is redundant, so I throw away the last one. And then I am searching for C transpose minus alpha transpose A tilde. A tilde is what? Now A tilde is obtained by deleting the last row. Okay. So that is what I am trying to search. Search what? Now I am searching for alpha transpose such that this has basic entries 0. All the basic entries are 0. You already have the basic BFS. You already have the BFS and the basis information. So now you are saying, okay, I have to find some alpha transpose that it has basic entry 0. Then you say, why searching alpha transpose? Let me search something like this. Let me search a beta transpose of this form, such that this has basic entry 0. Because here in A I have included the last row, but the corresponding entry I have made 0, and these two expressions will be the same vector only. So the idea is that the moment you can get a beta transpose such that C transpose minus beta transpose A has all basic entry 0, then you have computed the C bar. The C bar transpose is nothing but in that case C transpose beta transpose A. That is the idea.
Yes, sir, I understood it now, sir. Thank you, sir.
Okay. Now suppose that you have done that. Somehow by magic you have got that beta, and now you have C transpose minus beta transpose A, which is nothing but C bar transpose. You have done. Okay. So for basic variables C bar ij, so the xij basic variable, then C bar ij will be 0. That is automatic. But what is the condition? Now I should have C bar greater than equal to 0. So that means at a non-basic variable. So basic variables anyway, I mean in C bar the basic variables are always, the basic entries are always 0. So in the non-basic part, it has to be greater than equal to 0. Okay. So what is that you are going to do? Now I am going to compute this beta transpose A, Achha, that beta transpose A has okay. This C transpose is a big vector. Huh? Beta transpose is because A has two parts, right? A has the source part, the first M, and the next. So this is 1 to M, and then it is M plus 1 to N. This is A. Okay. These many parts. So correspondingly, you write the entries of beta U1 up to UM. Give me a moment, please. Hello. Sorry? No. This is wrong number. Ha. So you write these entries V1, V2 up to Vn. And your Vn is the last one, which is 0, but doesn't matter. So you have C transpose minus this much. Okay. And you want to compute what? Now you want to compute I want to check whether this difference is greater than equal to 0. At where? Now at non-basic place. Non-basic place. Suppose that xij, okay, suppose xij is a non-basic variable. Suppose this is a non-basic variable. So how will you compute this? Now I will look at the ij x, the entry corresponding to xij. The entry corresponding to xij of C transpose will be Cij. That is fine. And then minus, and then the xij column, the column corresponding to the non-basic variable xij, that I have to multiply with beta transpose. Oh, but that column I know, that column is ei divided by, I mean not divided by, ei slash ej, right? So in that case, I will be multiplying this vector u1 to um, v1 to vn with ei ej. So that will be C bar ij. But then this one is actually nothing but Cij minus ui minus vj. Okay, so the moment you have got your magical beta with Vn equal to 0, then what is the relative cost for a non-basic variable? In fact, even for a basic variable, this is also true, that C bar ij is equal to Cij minus ui minus vj. Okay, so all you have to do is that, and on basic variables, of course, this becomes 0. And on non-basic variables, this has to be greater than equal to 0. So that is your test. For non-basic squares, you should have this. And this entries of beta, that is those ui's and vj's, they are called simplex multipliers. Now you will say, did I somewhere I am supposed to say something, and that is okay. And how do I compute this one? Achha, doesn't matter. I can say that. Okay, no problem. Now the only thing that is remaining is how shall I get a beta like this? The moment I get a beta, then what I can do, I can easily compute C bar ij. It's just Cij minus ui minus vj. So I see whether it is greater than equal to 0. If it is not greater than equal to 0, then I say okay. I do not say anything. If it is greater than equal to 0, I say it is minimal. Okay. So that is how to test the minimality of a basis. So first what you have to do, now highlight, so in the transportation table, highlight the basic squares. Okay. Now here is how you compute. Oh, I will come to this. Maybe let me take you to one example. I have a basic square. So here is an example. And how do I compute that magical vector beta? Now the algorithm says you highlight your basic square. So these are highlighted. Wherever the numbers are written, these are highlighted. Fine. See, after this double line, these are AIs, and below the double line, they are the BJs, demands. Okay. Now what you do? Now, see, this is going to give you a tree. It is going to give you a tree. So what you do, you start from the pendant vertex, or you follow that which one? Strike off procedure. Yeah. So you write, then you write U1, U2, U3 here, and V1, V2, V3, V4, V5. I have 3 by 5 transportation, and you put V5 equal to 0, because that was corresponding to my last column. Now on the basic square, what I know is that Cij on a basic square minus ui minus vj, that is equal to 0. On a basic square, the relative cost is equal to 0. That means Cij will be equal to ui plus vj. Now this is a basic square. V5 is equal to 0, so it gives me that u3 has to be 7. So this is equivalent to saying that Cij on a basic square is equal to ui plus vj. So this is 7. 7 has to be this. The moment I have u3 equal to 7, apply it on this square 3, 4, where it is 30. What will happen? That will say v4 has to be equal to minus 2. The moment I have this, so I am following the strike off procedure, or you can also go through the tree also via the pendant vertices. Because v4 is minus 2 and this sum is 5, so this has to be again 7. Now because this is 7 and this cost is 3, so here I should have minus 4. Looking at this one. Now because V3 is minus 4 and here I have Cij 2, so I should have this equal to 6. Now once this is 6, because of this 1, I will have a minus 5 here. Because this is 4, I will have a minus 2 here. So what is my beta? Now beta, actually you don't bother, but if you are very much interested, the beta is 677 minus 2 minus 5 minus 4 minus 2 0. This was your beta. Anyway, so you have computed the beta. Then what? Then what? Then I have to look at the non-basic squares and see if Cij minus ui minus vj is greater than equal to 0. On this basic square, do not compute. It will turn out to be 0 only, because this is how you have evaluated. Okay. So on here, for example, on this one, the 1/4. On 1/4, 6 minus 6 plus 2. So I will have 2. So C bar, if I want to write, C bar will be 0, 0, On basic square it will be 0. Here it will be 2. On the fifth one, that's 9 minus 6 minus 0, 3. On the 2/1th square, the first square of second row, 6 minus 7 plus 2, 1. 2/2th square, 4 minus 7 plus 5, 2. Then the two basic squares, it will be 0. What about 2/5? 7 minus 7 minus 0, that is 0. What about 3/1th square? 6 minus 7 plus 2, 1. What is the next one? 2 plus 5 minus 7, 0. Next one, 3 plus 4 minus 7, 0. Next two are basic squares, it will be 0. So that is your C bar matrix. Okay, and this is greater than equal to 0. Therefore, you compute that the current BFS is minimal. Okay, so that is what it is. Acha. So what was that algorithm? The algorithm says highlight the basic squares in the transportation table, write U1, U2, UM at the right end, and then V1, V2, Vn at the bottom, and then you set Vn equal to 0, and then make sure that on the basic squares Cij becomes Ui plus Vj. So using that you have to compute Ui and Vj. Because your graph is a tree, you will be able to compute it uniquely. This will give you a unique solution. Okay, and then you try to see whether Cij is greater than equal to Ui plus Vj all on non-basic squares. If it is true, then you say W is minimum. Now why it is uniquely, you will be able to compute it uniquely. Now say suppose that you have a tree. Draw some tree as you wish. Okay, and then you have your U1, U2, and okay, weighted tree, because the Cij are the weight. So let me write the weights here, something like I write 1, 2, 2 is the bottom one, 3, 4, 2, 5. Okay, U1, U2, U3, V1, V2, V3, V4. Okay, and you have taken V4 equal to 0. Now on the edges that you are seeing, what are they? Now they correspond to the basic. Remember, they correspond to the basic variables, right? So on a basic variable, the Cij will be equal to the Ui plus Vj. So that is this 5 must be equal to U3 plus V4, and therefore the value of U3 is 5. Now the moment value of U3 is 5, the sum of the endpoints like U3 and V2 has to be equal to 2. So V2 is equal to minus 3. The moment V2 is minus 3, sum of the endpoints have to be equal to, because it is a tree, you can proceed one after another. So this will give U2 equal to 6, because the sum of U2 and V2 has to be equal to 3. At the moment you have U2 equal to 6, you can determine V3. V3 will be equal to what? Now V3 will be equal to minus 2. What will be V1? Now V1 will be equal to minus 4. And the moment V1 is minus 4, you know what is U1. U1 has to be equal to 5. So given a weighted tree and the condition that weight of each edge is the sum of the endpoints. Okay, weights of the endpoints, you can say like that, and one endpoint is weight is given. Okay, then you can compute the rest. Okay, so that is why you can compute it uniquely. Now, how to get an improvised BFS? Say, assume that you had a BFS, so you created the transportation array. Okay, and just as I did here, and then computed C bar. Okay, and in that C bar you are seeing some negative entries. Then what do? Now, the moment I saw in earlier time, when the moment I saw C bar, I used to like I used that variable. I could use that variable as an entering variable. Okay, but there I had one thing, that in my simplex table in C bar I have some -2, suppose here, if it is xk, that was my entering variable. This was simplex table, and if this column was entry wise less than equal to 0, so earlier time I concluded that the problem is unbounded below. Okay, that actually resulted in a direction like in an infinite feasible ray along which the function is decreasing. So it will go to -infinity. But here in the BTP, the cost function is bounded below, in fact bounded above also, because whatever is the the smallest minimum cost. Okay, whatever is the minimum cost, you will look at the minimum cost per unit and then multiply by the total amount of unit you have to transport. So your cost cannot go below that, right? It will always cost you more than that. And whatever is the maximum per unit cost, wherever among all possible roads, all possible transportation, and in total assume that you are transporting 1000 units, well, uh, that is the maximum possible cost. You cannot, in whatever way you distribute, you will never be able to spend more than that. So anyway, it is bounded. So therefore, such a situation will not come, that all these entries less than equal to 0, that is the unbounded situation, will not come. That means you will always find some entries over here which are positive. That means you are going to get an outgoing variable. Okay, so you will always find an incoming variable. Not always find, but the moment you have C bar has negative entries, that is your incoming variable, and you will always find an outgoing variable. Now, to get this outgoing variable, there is a simple graph theoretic technique. Now, what you do now, remember, so suppose that this is your C bar ij was negative, and once C bar ij is negative, and so that means xij was non-basic. Currently it is non-basic, and you want to enter that, so that one is coming. So right now its value is 0, you want to increase its value. Okay, what do you have now? I have s corresponding to the basis. Okay, something like xi1 j1 xi2 j2, all this thing. My, so this is my basis. the current basis. And I want to make Xij basic. Now, if I want to make Xij basic, out of the basic variables currently, one I have to throw out, make it non-basic. How do I select? Now remember, gamma S is a tree. And if I consider S dash is equal to S union Xij, I put another edge. What do I get? Now I will get an unicyclic graph, right? So you have a tree and you have just added one more edge. Since you have added one more edge, this is an unicyclic graph, and you will be able to detect that cycle easily. So what happens now? What cycle you have created? Now I have introduced Ij, that I have introduced, and because the earlier graph was a tree, it has created a cycle. So suppose this is the cycle it has created, like this. This is I1, J1, and then finally Ik, Jk, and Jk to I. This is the cycle it has created. Fine, no problem, it has created. And I have to break the cycle. That means I have to throw away one old edge. Okay, and what do you want to do? Now I want to increase Xij from 0 to theta. I want to give a value theta. Xij I want to make theta. But wait a minute, you had basic solution, right? So all the values, all the outgoing, all the transportation going out of I, the source I, that total was Ai. If you just increase this one to theta, somewhere you have to adjust that, na? So then the idea is you adjust this theta from this I to Jk. Okay, so here whatever it is, you make minus theta. Similarly at J earlier it was receiving from everywhere. Okay, wherever it was receiving, it was receiving complete Bj amount. Now it is going to receive an additional amount theta from I. So that has to be adjusted. So what you do, now every alternating edge, you increase and decrease theta, whatever was happening. Every alternating edge, you increase and decrease theta. Here minus theta, here plus theta, here minus theta. Okay, so if I put it in a cycle way, remember this is a cycle in the bipartite graph. So because in a bipartite graph, the total number of edges will be even. Okay, cycles. So if I just put it in cycle way, so this is Ij, I do this way, then J to I1, I1 to J1, and similarly Jk to I. So if you increase this as theta, whatever was the value Wi1, J1, J, whatever was the value, okay, earlier whatever that you decrease minus theta. Then here you increase theta. Here whatever was the solution, decrease minus theta. So this has to be done so that the system of constraints, that those constraints remain satisfied. So in that case, what is the maximum amount of theta that you can give? Now it depends on what are actually the values over here from where you are taking away theta. Whatever was those things. So depending on them, and I can choose the maximum of theta so that one of those, this thing, turns out to be 0. If that turns out to be 0, 1 or at least 1 turns out to be 0. If that turns out to be 0, you throw, that is your, delete that edge, break that edge. Okay, so earlier you had a tree, you added one edge and you deleted one more edge from the cycle itself. Therefore, the resulting graph will also be a tree, and hence this is how you get your new BFS. Whatever you are getting is a BFS only. It is a basis because it is corresponding to a tree, and everything is greater than equal to 0. The non-basic things were anyway, I mean, they are greater than equal to 0. And in the basic things, you ensured that just, I mean, by choosing theta carefully, everything remains greater than equal to 0. Okay, so that is how you select your, let me go to here. Okay. So here what do I do? First I check U1, U2. So this is U1, U2. Let me simply write over here U1, U2, U3, then B1, B2, B3, B4, B5 is equal to 0. Okay, and these are the basic squares. Okay, so instead of that, so because of the basic squares, as you are used to it, so this will be 8. Because this is 8, this is 4, this is -4. Okay, erase this. This is -4. In fact, I don't have to write, you remember this is. Okay, and because this is -4, on the top you have 5, so you have to have a 9 over here. Okay, these are the basic squares, huh? Where we have this. Okay, since I have 9, this is -3, this is 3, so I will have a -6 here. Because it is -6, this one is 2, I will have a 8 over here. 8, 1, this one is -7. 8, 4, this one is -4. So UI Vj computed. C bar matrix. Now C bar, the relative cost matrix. 0, 0, 0, 6 minus 8 plus 4, that is 2. 9 minus 8 minus 0, 1. 6 minus 9 plus 4, that is 1. 4 plus 7, 11 minus 9, 2. Basic 0, 0. 7 minus 9 plus 0, so minus 0, that is -2. Okay, we have got a negative entry. Okay, 5 minus 8 plus 4, this is 1. 2 plus 7 minus 8, 1. 6 plus 6, 12 minus this is 4. And then the other two are basic squares. So this is C bar. So this is not good. Not good in the sense this is not minimum. But I have found what? Now I have found this one. One entering variable. What will be the entering variable? Now the entering variable will be x to 5. Okay, fine, x to 5. Now let me see what are the this thing here. 1, because it is first time I am doing it. 4, 5. What are the basic squares? So what is gamma s for my basics? Basis s. 1 to 1, 1 to 2, 1 to 3. Okay, and then I have 2 to 3, and I also have 2 to 4, and then I have 3 to 4 and 3 to 5. This is my gamma s. In gamma s, what do I do? So this is 1, 2, 3. 1, 2, 3. Actually, it is better to write A1, A2, A3 so that you don't confuse B2, B3, B4, B5. What are you adding? Now I am adding 2 pipe. 2 pipe I am going to add. Okay, this is my 2 pipe. So what is the cycle that I am going to get? Now A2 to B5, B5 to A3, A3 to B4, B4 to A2. So if you actually see in the table itself, okay, you have this one, this one, this one, then this one, and then this one, this one. Okay. So this is where you are trying to add theta. Now, because this is the theta, what it is saying, now here is the cycle that is being formed. Okay, the cycle is being formed over here. You are trying to add theta and it is being formed over here. Okay, this is what? 2 to 5 and 2 to 4, that means this one. Okay, and then 3 to 5, this one, and 3 to 4, this one. Sometimes cycle can be formed like this, like this. Cycle can be formed like this. Here it is coming like a square. So if you want to increase this as theta, you will have to subtract theta here. You have to increase theta here, and you have to subtract theta here. So what is the maximum possible value of theta? Let me erase these things. So what is the maximum possible value of theta? Now, since I have to do minus theta, I understand that the maximum value of, okay, so this part is not necessary. Huh? So we get theta is equal to 60. If theta is equal to 60, then I know this A24 is going to go out. That is becoming 0. If there are more entries becoming 0, you can throw any one of them. So that is going to go out. So what is my next basic solution? Now my next basic solution is the following. My next basic solution would be 40, 50, 10, 60. This 60 was 60. Now this becomes non-basic. This has become 60. And this is 90. And this has become 30. This is the next basic solution. Okay. Now you compute C bar. Again, the same way. You put a 0. I have to find something. On the basics, anyway, it doesn't matter actually. On the basic square, you have put a 0. On the basic square, it has to satisfy Cij is equal to ui plus bj. So this has to be 8. That is hard. It has to be satisfied. This has to be 7. Now because this is 8, this will be minus 4. And because this is 7, this is minus 4. Because this is minus 4, this has to be equal to 6. Because this is 6, this has to be minus 5. Because this is 6, this has to be 2. Okay. The new C bar matrix. Now that we have done, we know it quickly, we can do without making too much of this thing. 0, 0, 0, 6 minus 6 plus 4, 9 minus 6, 3, 6 minus 7 plus 2, 1, 4, 5, and 2, and this one is 0, 5 plus 9, so that is 2, 0, 7 minus 8 minus 1, 7 minus 8 minus 1, 10 minus 8, 2, 0, 0. What is the entering variable? Now I will take this one. So if that is what I want to make theta, so I will put a theta over here. What will be my cycle? Now cycle would be this one, this one, this one, this one, this one, this one, and again back to this one. Okay, back to this. Cycle will be that. So you can draw the tree and see I am telling the correct, and you will have a unique cycle only. So if this is theta, okay, you will have, if I increase theta, you will have a minus theta, you will have a plus theta, you will have a minus theta, you will have a plus theta, you will have a minus theta, and you have plus theta here. So what is the maximum value of theta that I can take? Now wherever you are doing minus theta, you look. So theta is 30. So what is the next? Now the next one is the following. 10. What goes out? In that case, 3, 5 variable goes out. 5, 40, 30, 90. This one is going out. I have 90, 30. Your next BFS. This is your next BFS. Again compute C bar. If it is greater than equal to 0, fine. Otherwise proceed. So that is how you do. Here I have done that ultimately. Okay. So that is how you finish it, the BTP. So the algorithm is basically this. How to find initial BFS? Now you can apply northwest or start randomly. That is also fine. As long as you get a tree, that is a basis. But to get a BFS, either you go northwest or select any variable, select the minimum, whatever. Okay. So this is the algorithm. Okay, then we shall stop here. And now we should go and uh, uh, some student wrote that there are some 2-3 places where you have already given the mock test where that is using code tantra. Hello.
Yes, sir. In another course, we have written a mock test using Code Kantra already.
So it is basically here also it is the same thing. It is basically to let you know whether you are able to use it. So just give 2-3 minutes. So I will do it. You do not leave this group, and let me open that exam. Okay. And I just want to ensure that you are able to log in and you are able to see the exam paper. If you are able to do that, then I am fine. I don't have a problem. So let me do that. Okay, I am enabling the test. Are you people able to see it? Just check.
Sir, saw it.
Able to see it, na?
Yes, sir.
And then you know how to, I mean, take photos and then make a PDF and then submit. You know that?
Yes, sir. We had a similar mock test in other course.
Okay. In that case, that is fine. So I just wanted to see like whether things are working. If you already know, that is fine.
Sir, we had a mock test, but actually, quite a few students had problems with the code tensor platform. Like we were able to do, but it's a bit complicated, the file upload and all this PDF system. So many of us felt that maybe Teams can be a better alternative for.
अरे टीम वो लोग थोड़ी अलाउ कर रहे हैं. See, like actually they are, see, the academic section is saying according to the rule the exam has to be proctored, and then we are, so academic section from its own side is suggesting you use code tantra, and then it is saying like academic section is not forcing on faculties to only use code tantra. A faculty can use some other things like Teams or any other things, but then the total risk will be like completely of the faculty. So I have no idea how to make a proctored exam, what to do with Teams. So I have no idea. I do not know. Even for code tantra also I had to like learn what to do, all these things. So actually I do not know how to make a proctored exam and how to proctor, I mean how to divide and then make people see you. That thing I do not know. So that is why. Is it easy in Teams?
Yes, sir. Actually, we had some courses and SEMs on Teams
Who?
using Proxten last
Ha,
semester.
which
Uh,
sir?
Databases, I think.
Database, who, Parthatat or Gautam?
Saradi sir and Rashmi ma'am.
Oh, acha,
Manas
from
Katwa
CS.
sir also.
Okay. Saradi, sir. Okay, it's okay.
Sir, in that it was like one TA was responsible for 10-15 students and they all had a video call, and the faculty sent the paper over PDF. So while we were solving, the TA could see our faces.
Oh.
Yeah.
But here we do not have, first of all, this arrangement of TA and other thing that the department gives few research scholars, and this time it is like everybody is demanding many. I do not know. I probably will get 7 or 8 maximum. So each person would be seeing about maybe 20-25 students. I have no idea. Anyway, it is too late for this one. It is too late. I had no idea of how to do. Actually, I just said you give me a link where I will give my PDF file and they will upload their PDF file. They said no. It will not work like that. They have to see your face. And I did not know, yesterday only I came to know that they would require 2 devices. Yeah, so these things is like not at our hands. And anything extra, if I am trying to use anything other than code tantra, then I personally will be accountable and responsible if even an epsilon amount goes wrong. I will be questioned. Who asked you to do that? We suggested this. That's how it is. And for you, acha, at the worst case, you know what to do. If you are unable to submit it there, then at the worst case, the exam will be from 2 to 4. Immediately within 4.01 or something like that, you send it to my email. Okay, anything goes wrong, if you are like having trouble there, you
But sir, we cannot change tabs on Code Tantra, right?
not tabs, but whatever answers you have written, उसका फोटो लेके PDF बना के मुझे भेज ही सकते हो ना.
But on laptop, you are not allowed to change tabs.
But the exam will finish till then, na? What are you saying?
But sir, in 1 minute making
No, no,
PDF.
answer you will be writing on paper only, na.
Okay, okay. Okay, from using mobile. Okay, okay.
हाँ, पेपर में तो लिखे होंगे ना. यू टेक फोटो, एक स्कैन करके पीडीएफ करो विद इन 1 minute 2 minute. आई एम सेइंग, सो व्हाट आई एम सेइंग इज बाय 4:05 or something like that. 4 o'clock 5 minutes, 4:05. Okay, so I will write that instruction in the question paper itself, that if you are facing difficulty, at the worst case, if you are unable to upload it to the Code Tantra as a PDF file, you do one thing: take your mobile and make a PDF file out of it and send it to my email. And that you should do within 5 minutes, let's say 4.05. I mean, that is what it is. That part can be done, na? And after all, it is me to consider, so I will consider that. But you try to submit in that Code Tantra itself. I do not know what this academic section is planning, what they will do. That I do not know. So submit something there that you have submitted. Any doubt?
TAs would be there, right? With whom we can contact during the exam.
Yes. Till now, the department has not allotted me a list of TAs. I am believing I will get a list of them, and then they will be allowing you to enter the exam.
And also, if in case we get blocked, they would have the authority to unblock us, right?
They should. I have no idea what are the things they are allowed. That I have no idea. But in any case, I will be there. In fact, these Code Tantra people would be there. I mean, actually this is first time for me also. I have no idea what these people are doing, but I think they should have. Otherwise, why calling them proctors? If they do not have the, I mean, if you get blocked, if they would have definitely the power to unblock.
Okay. Sir.
Excuse me, sir.
Yes.
Sir, can you after the test starts on Code Tantra, can you share a PDF of questions on Teams as well? Like if at all there is some internet issues or they block us from Code Tantra, we can refer to these questions.
True. The exam there will start at 2. What I will do around 1:59 or so, exactly at that time, the moment the exam, I have to enable it. The moment I enable it there, here also I will post the question paper in the Teams app. That I can do. So you can, in case you are unable to, but that should not be the case. You people are easily able to see what I kept as, like whatever PDF I kept. But still, I will keep, no problem. PDF file. I hope things go correctly. So I will tell these things, the TAs, to know these necessary, I mean, enable, disable, all these things. That if somebody gets blocked, then how to unblock. So I will tell them. So that will be on 23rd. Our exam is on 23rd. By that time, I am sure they would have learned. The most of the problems will come on 20th, 21st. So by 23rd, they would have learned it, definitely.
Sir, if you will allow submissions through mail, so will there be a deadline for that as well? Like
Deadline?
within 30 minutes of the exam, if you weren't able to submit, you have to send it through mail, yeah, within 15 minutes as well.
No. I said by 4.05. In case, so exam time is from 2 to 4. And this is Code Tantra. I do not know whether it will allow you even a single second more. That I do not know. But, and you honestly, if you are unable to submit your answer script there, then what you do, make a PDF file by scanning with your mobile, as you did in the quiz and send it to my email.
Okay.
And that you have to send by 4:05. 5 minutes is fine, na? Because anyway after 4 it will stop accepting anything from you.
Okay, sir.
Sir, actually in Code Tantra, we don't have to make the PDF. The software automatically makes the PDF for each question. It will ask us to submit separate photos. So after the exam, we will have to click all the pages and then submit. So maybe a bit more time, like 4/7 or 4/8. I mean to say, we have to remake the PDF. That PDF will not be with us, which we have submitted to Code Tantra.
No. Anyway, this 2 hours that I am saying, that itself is long. See the total mark will be like the question is like which type. The total mark will be 20 only. There will be 30 mark question. You will have enough time.
Okay.
I think by 1 hour 50 minutes is actually the time. It is more than the time you would require. If you have your understanding, you would be able to answer maybe about 65% of the question. It will basically say what is that, compute this one, compute that, what is this, all this. So those are the basic questions, and then 1 or 2 questions from exercises, and then there will be one question which is kind of new where you have to think.
Okay.
So by that I think the majority of the question, 65% or 60% of 30 means about 18 marks, na? Okay, so like around I would say that. So about 18 marks out of 20 you can score if you simply have your understanding. What is this, how to, what is that, all these things.
Okay, sir.
Okay, so you would actually not require more time. You imagine that the exam is 1 hour 15 minutes and then that 10 minutes. I also have looked at this Code Tantra, this thing. It says you take a snap, all these things you take. So I took actually 2-3 snaps and then submit it as a PDF. I don't know what it submitted, whether it submitted as separate PDF or single PDF, that I do not know. That I have not checked.
Okay, sir.
Okay, so it should not be a problem. And in any case, you would be writing the exam on 20, 21st and 22nd. Na? If you are seeing that there is too much of problem getting created on 28th and 21st, if you see that, then you inform me. The class representative can write to me on 22nd itself. Ki sir, Code Tantra is creating a lot of problem. We want this. As simple as that. If it is creating a whole lot of problem, I believe it will not. So because they are going to use it. So let's see. I will. You will let me know if there is too much of problem. You let me know. But according to the rule, the exam has to be a proctored exam. So in case I decide not to use Code Tantra, then I will have to take permission. I don't think Dean will give permission because this exam has to be a proctored exam. It is by the government, I think. Notice from the ministry. They cannot do anything. That is what my understanding is. Okay, in any case, you be ready. Acha, Friday, this Friday I will not have class. Okay. We'll meet you on the exam day. Fine enough?
Yes, sir. Yes, sir.
Okay, good. So syllabus is up to this. Today, whatever I have taught, that included. Okay then.